I'm going to shorten the title of the notes to as follows. It is definite integrals using area. Definite integrals using area. What to talk about is how to find the calculus way of writing definite integrals, specifically with geometry formulas. So let's review real quickly what a definite integral looks like. It looks like this. You have the integral symbol, the a and the b, and the f of x dx. That's what a definite integral looks like. And what it represents is the area under s from x equals a to x equals b. The area under f of x from x equals a to x equals b. So you have to keep straight what's x information and what is y information. The a and the b are x's, and the f of x is like a y. Okay? So what we're going to do is I'm going to give you some calculus equations and calculus definite integrals. For example, the integral from 0 to 3 of 7 dx. We are going to figure out what that's going to be, what that area is going to be, because we're going to draw it. It's going to create a shape that we know from geometry and that we can use geometry to find the area of. Okay? So, what does this mean in a graph? That's what I want to talk about first. First of all, it says from 0 to 3, which means it's only quadrant 1. Okay? Because these are x values. So I'm going from 0 to 3. So over here, draw a quadrant 1 graph only. Because these are x values, they go on the x-axis. So we're going to put a 0 right there and a 3 right there. Those are the only two numbers we need. Okay? Now, the 7 is a function. F of x equals 7. And that's what we're going to graph. What does that graph look like? Straight horizontal line. Agreed? What is its y-intercept? 7, right? So I'm going to estimate, 7's right there. Just pick a point and put 7. And then draw in your horizontal line like so. So the limits of integration, the a and the b, tell you what to mark the x-axis on. The equation that's here tells you what to graph. And the whole thing together means find the area under this graph from here to here. Yeah. Okay, so what shape are we talking about? Well, I don't have anything closed off yet, so what I need to do is draw a line from the graph to the 3. What do I have? A rectangle. So I'm going to shade that in. Rectangle is base times height, so the area is what? 21 units squared. You're done. That's all you got to do. So the trick to doing this is interpreting what does this calculus symbol stuff mean in a graph, and then using the graph to find the area. That's what we're doing. Okay? Part of what we're doing today. Let's do another one. Integral 0 to 4, negative 2x plus 8 dx. Are we only in quadrant 1 again?
Yes.
Yes, because it goes from 0 to 4. So that's quadrant 1. So I'm going to label 0 and 4. I don't care how far over you go. Okay, got taken care of the 0 and the 4. Now let's take care of the graph. What kind of graph is this? It's linear. Does it slope this way?
No.
It slopes this way. Okay, so what's its y-intercept? 8. So I'm just going to pick a point, call it 8 right there, put a dot. Okay, now my question is, if it's sloping this way, where is it going to hit the x-axis? Before the 4, after the 4, or at the 4? So take that 4 and plug it in here. What do you get? You get 0, so that means it's hitting right there at the 4. Does that make sense? So now draw your line in that you said it was going to be. And we have already closed in the shape, so we're talking about a right triangle. I'm going to shade that in. What is the formula for the area of a triangle? 1/2 base times height, which in this case will be 1/2 of, what's the base? How long is it? 4. What's the height? 8. What's the area? 16 square units. Okay, let me stop for just a minute because we're getting into an area, that we do need to discuss about the AP exam. Okay, now, on the AP exam, I don't know if I've said this before, but I'll say it now. You do not get a formula chart of any kind whatsoever. Okay, now, you can program stuff into your calculator, but you only get to use your calculator on less than 50% of the test. Okay, so what does that mean as far as this is concerned? There are problems, as you see, that require geometry. You are expected to have the area formulas for all geometric shapes memorized. Okay, circles, squares, triangles, rectangles, parallelograms, trapezoids. Area is only 2-dimensional. Okay, I will address the 3D issue. Okay, no, actually, I'll take that back. Surface area is 3-dimensional. And I have yet to see a surface area question on the AP exam. Okay, so no, they will give you surface area problem. If there's surface area, volumes I wanted to discuss. Okay, when it comes to volumes, if it's a regular prism, in other words, if the base and the top and the bottom are the same shape, like a cylinder or a cube or a rectangular prism, they expect you to know that because it's always the area of the base times the height. Okay? Not those. If it's anything unusual, like a sphere or a cone or a pyramid, they will embed the formula in the problem. Okay? We'll do some of those as we get closer to the AP exam. Because they don't want you to miss a calculus question because you don't remember a geometry volume equation. Does that make sense? Related rates is usually 2-dimensional, so you wouldn't need it for that. But later on at the end of the year, we're going to talk about finding the volumes of really odd shapes. And if it's based on a sphere, for example, they'll give you the formula for the sphere. Okay? So I wanted to say that now. But all of these formulas in here, you better know them. If you don't know them now, you need to learn them. Okay? So, next problem. The integral from 0 to 3 of 4/3 x plus 3 dx. Quadrant 1? Yes. 0 to 3 again. What type of graph? It's still linear. Does it slope this way like before? No. It slopes this way this time. Okay, that's going to make life interesting. What's the y-intercept? 3. And then it's going up from there, so I didn't put the 3 very high. So, we need to know where it's going to hit the 3 on this side, so substitute 3 into this equation, and what do you get? You get 7. You get 4 for the first term, and then you add the 3, which gives you 7. So up here, it's going to go through the point 3,7. And the line is going to go through those 2 points like so. Okay? Now, just like the first one, I had to drop a perpendicular down to the x-axis. I got to do it again. So I have a closed-in shape. What shape is this? It's a trapezoid, just like we did on the trapezoidal rule yesterday. Okay? Or you can do it, if you want to, as a rectangle with a triangle on top, but that takes more work. You need to know the trapezoid formula anyway, so let's use it. So it is 1/2 the base times the sum of the heights. 1/2 b h1 plus h2. In calculus, 99.99% of the time, the trapezoids are going to be this way, on end. Okay? So might as well just do it that way. Okay. How long is the base? It's 3. It's the distance across the bottom. The heights are the 2 sides that are parallel. So the left side is 3, the right side is 7. So plug those in. I don't want to do half of 3, so I'll multiply 3 times 10 first. 30. Half of 30 is 15 square units. Okay? Questions? All right, one more. Then we're going to go on to something different. The last one, we're really going to make a change. Integral, -2 to 2. We're going into a different quadrant now. The square root of 4 minus x squared dx. Okay. You're like, I don't know what that graph looks like. That's okay. We're going to talk about it. You are going to learn today to add one more to your list of all of your functions that you're supposed to know what they look like off the flip chart you made in Algebra 2, right? Is there anybody in this class who was not at Reagan for Algebra 2? Nobody? So everybody in here made a flip chart, right?
Yes.
I love those flip charts.
Can we make another one?
Maybe? Okay. No, like one for calculus. Actually, the VC kids make one for sequences and series. Okay. So now we need to draw two quadrants, 1 and 2, because it goes from -2 to +2. -2 to +2. Now, if that x was not squared, I think you might know kind of what it looks like. Do you know what a square root graph looks like? Yeah. It goes kind of like that?
Yeah.
Okay, half of a parabola on its side. The squared, however, makes a huge difference. So what we're going to do is we're going to do some algebra and kind of rearrange the way this looks, and I'm going to show you that you actually do know what this is. It's just in a different set of clothes. So come over here and write this down. Y equals the square root of 4 minus x squared. Let's do some finagling, as you would call it, to that equation and see what it really is. First thing I want to do is take the square root off. How do you do that? Square both sides. So what's the left going to be? Y squared equals, what's the other side? 4 minus x squared. Okay. Now maybe you know what it is, but if you don't, put the x's and y's together. Move the x squared over. Put it in the front. It is a circle. X squared plus y squared equals 4. Okay. What is its radius? 2. It is 2. What is its center?
0.
0, 0, because there are no numbers with the x and the y. Okay. Now, it is really not a full circle because of the fact that it's under a wrap. It is actually the top half of the circle. Okay?
How do you decide that?
Because it's a positive square root. How do you make an equation flip over the x-axis? What do you do to it? You put a negative in front of it, right? So if this had said y equals the negative square root of that,
So
it would be the bottom half.
Minus x squared, it would be...
No, that's a hyperbola.
No,
But whenever you square both sides, you create extra stuff. That's not really true part of the graph. So if I solved, okay, let's say I went backwards. Let's say I took this and solved it for y.
Yeah.
First thing I do is move the x squared over to look like this. But then I take the square root of both sides, and what have we always told you? That whenever you physically take the square root of both sides, you always put on your answer plus or minus.
Oh.
I'm only doing the plus. So that's giving me the top half of the circle. The minus gives me the bottom half of the circle. Okay? So it goes from here to here and also goes up to 2 and does a semicircle thing like that. The top half of a circle. Okay, I don't know why I wrote an A, but I did anyway. What is the formula for the area of a semicircle? 1/2. Okay, please don't get circumference. It is pi r squared. The one that is square units is the one that's area. Pi r squared. So it's 1/2 pi. Leave the answer in terms of pi, by the way. The radius is what again? 2. So what's the final answer? 2 pi square units. Questions? 2 pi square units is the area of that thing. Okay? Anybody else have a question before we move on? Okay. Now we're going to do a second topic, which is dealing with properties of integrals. What are you allowed mathematically to do to integrals? That's what I want to talk about next. So, like I said, this is not very hard. It just looks kind of funny. Don't think it's that funny, but. Properties of definite integrals, and there are 5 of them. We're going to write the 5 properties down, and then we're going to do an example dealing with them. Are you allowed to add integrals? Are you allowed to multiply integrals? Are you allowed to subtract them? That's what we're going to talk about. What can you do to them? What are you allowed to do to them? Okay. Now, what you need to put in your brain about integrals. Let me talk about derivatives for a minute. What are some of the words that I've talked about that are synonymous with derivative? What is derivative the same as?
Differentiable.
Differentiable. But what's a word? Slope. Rate of change. Things like that. The word I want you to put with definite integral is area. So anytime you see a definite integral, your brain says area. Okay? So the integral from a to b of f of x dx is equal to, now this is a little weird, the negative integral from b to a of f of x dx.
But isn't B
That's what I'm going to talk about. Hang on just a minute. Okay. I think I kind of lost you. Okay. All the ones that we did on the first page, the A number was always smaller than the B number, right? And we always went from A to B. Agreed? What this is saying is that when you go from B to A, it gives you the opposite sign for an answer, which now means there is such a thing as negative area. Okay, now, don't let your brain explode. Let me say this. Go back to trig for a minute. Didn't you learn in trig there's a negative angle? What makes an angle negative? It's the direction in which you rotate it, right? So for positive angles, we rotate this way. Negative angles, we rotate this way. Negative area just means what direction you go. If you're going to do area this way, it's positive. If you're going to do area this way, it's negative. Okay? So, think about that for a minute. Negative area. Okay? Number 2. Integral. Okay. I need you to just chew on that in your brain for a couple days, and then we'll come back to it, okay? The integral from a to a of f of x dx equals. They're both a's. Okay, some of you are thinking the integral from b to b. Yes, it's that too.
Undefined.
It's not undefined.
Just that
It is,
Infinite.
Sibby said it, it's 0.
What?
How did you get 0? Okay, you're measuring the area from here to here. What's the area under the curve? There is no area because you're not going anywhere. So the area is 0. Does that make sense? Okay, number 3. Integral from a to b of k times f of x dx equals. Okay. K has always represented a constant. So the integral from a to b, if you have a constant multiplied in there, it is the same thing as k times the integral from a to b of f of x dx. So what did I do different? I just slid that k out of the integral, and guess what? You're allowed to do that. Because integrals, because I told you that constants just sit there, it can sit there inside the integral, or it can sit there outside the integral. It doesn't matter. Okay? So if that constant is in your way, pull it out of the integral. But it only works for constants. It doesn't work for x's. File that away, because later on you're going to want to pull x's out of integrals, and you can't do it. Can't do it. Okay? Now, there is a corollary that goes with this. A corollary, does anybody remember the word corollary from a previous math class?
Correlation. Oh, it's like which, isn't it like the way that they're all going, like a positive correlation?
Yes. Okay. Yeah. There you go. But there's a word corollary. Corollary is a geometry word actually. It's a twist on a theorem. It's taking a theorem and going a little bit farther with it. So I'm going to do that with this one. Look at this. The integral from a to b of negative f of x dx. Okay. If you have a negative inside an integral and it's in your way, can you take it out?
Yes.
Yes, because it is a constant. A negative is like a -1, which means it's like a k.
So it's negative integral.
So it's the negative integral from a to b of f of x dx. So if that negative's in your way, just pull it out of the integral. And you're allowed to do that. A lot of people think, well, wait a minute, that's a negative sign. That's not a number. Yeah, it is a number. It's -1, exactly. Number 4. The integral from a to b of f of x plus or minus g of x dx equals. Why is it plus or minus? Because it saves me from writing 2 different theorems. I can do it all in one. Okay? You have been doing this already. You just didn't know it. It is equal to the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. Now, can anybody tell me what that says in English?
Nope.
Okay. My second period, they were the same way. They're like, no. Let me get you started. If you are taking the integral of 2 things that are added, what can you do to those 2 things? Say it one more time, Isabella.
You can find each integral of them separately and then also them.
Yes. You can take the integral of each one individually and then add the answers together. Good job. Okay. Now, when you did the indefinite integrals worksheet, and I had like 3x plus 1, didn't you take the integral of the 3x and then you took the integral of the 1? That's what you did. It's exactly what you did. You've already done this. You just never wrote it that way. Okay? Number 5. Last one. The integral from a to b of f of x dx plus the integral from b to c of f of x dx is equal to what? Very good. Okay, remember this means area. The area from A to B plus the area from B to C is equal to the area from A to C, as long as the functions are the same, right? The integral from A to C of f of x dx. That's the last property. Okay. Questions on that last one? Okay. I'm going to do an example, and then we're going to be done. Okay. In the example, I need to go ahead. If you need to leave for the 8th graders, go ahead. I'm going to put down some given information. Here's the given information. The integral from -1 to 1 of f of x dx is equal to 5. Write that down. Comma. The integral from 1 to 4 of f of x dx is equal to -2, comma. And then the integral from -1 to 1 of h of x dx is equal to 7. That's the given information. I'm going to ask you some questions. Remember, these are areas. The area under f is 5. The area from here to here is -2. The area from here to here of a different function is 7. I'm going to ask you about some other areas. And using those properties, I want you to tell me if you could figure out the area or if you can't. And you just can't say you can't on all of them. Promise. The integral from 4 to 1 of f of x dx. You're right.
Ho-ho!
Okay. Which rule did you use to do that?
The one that you said about negative.
Rule number 1, isn't it? We just switched the limits of integration, so the area changes sign and becomes a positive.
Okay.
That was easy. Is that all you got?
No. If there's a part A, is that the only part there's going to be? No.
Maybe.
Okay. The integral from -1 to +4 of f of x dx. equals.
Oh, that's the adding one. Oh,
3 equals 3.
Those of you who see that it's 3,
3.
you see it? A lot of you are catching this really quickly. This is the one, this is number 5, isn't it? I'm going from -1 to 1 and then from 1 to 4. So -1 to 4 would be the 5 plus the -2, which is 3. Let me box these answers in. Okay, letter C. We're doing good. Because, okay, I was wondering if that question was going to come up. Let's go back to A for just a minute. Are any of you bothered by the fact that this one is a negative answer and it goes from a small number to a big number? Did any of you catch that? Some of you? Okay. Now, all the ones that we did on the front came out with positive answers. Let me show you why. Because all of these functions are above the x-axis. If the function's below the x-axis, it comes out with negative answer. Okay? Whoa, that was rather interesting. Good save. Okay. So that's why when you switch them, it turns positive. Okay, letter C. The integral from -1 to 1 of 2f of x plus 3h of x dx. Let me scoot it up. Okay. Which rule? Okay, first of all, we got 2 things added together, right? So that's like number 4. But I also have numbers in front of them, which is like number 3. Those are k's. So where do the k's go? Outside. So all in one step, I'm going to pull those numbers out and break it into 2 separate integrals, all at the same time. I'm just going to show you how it works. Okay? So you've got the 2, -1 to 1, f of x dx, plus 3, -1 to 1, h of x dx. Okay. All of this right here, what does -1 to 1 f of x dx equal? It equals 5. So this is really 2 times 5 plus 3 times 7, which is 31. Now, the question was asked, do I really have to show all of this? No, but I'm just showing you how it works. Okay?
So which rules for that?
3 and 4.
3 and 4.
3 and 4. Almost done. Hang on. I'm going to go really fast. Integral from 0 to 1 of f of x dx. Zero to 1. Okay. That sounds like a logical guess. If -1 to 1 is 5, are you guaranteed that 0 to 1 would be half of that? Only if it's symmetric about the y-axis it would be, but you're not guaranteed that. So this is one of them that you can't tell. You can't do it. You don't have enough information. All right? One more real quick. -2 to 2, h of x dx. I know -1 to 1 is 7. Is -2 to 2 going to definitely be 14? No, I don't know for sure. So this is also a can't tell. All right. Questions?